desktop, or even TV, all modern devices run on FinFET transistors. A transistor is a tiny electronic switch that controls the flow of electricity inside the circuits. You can think of it as a microscopic ridge of silicon with a thin fin sticking up. This FinFET device was a hero because it carried us through an entire decade of technological progress. From the first Apple Silicon to the GPUs that power the most advanced data centers on Earth. But its time was up. To keep shrinking transistors, the key structure inside it, the fin, had to become thinner and thinner. Imagine something just 6 nanometers wide and 60 nanometers tall. At some point, they literally started bending and snapping during the manufacturing. In fact, when the challenge becomes too complex, too expensive, and too risky to solve on their own, the world's biggest players, Intel, Samsung, ASML, TSMC, all joined forces with IMEC because all of them want eventually the same thing. A place that tests impossible ideas before spending billions trying it on their own. By then, IMEC had already explored every path they could think of, including new materials, new architectures, and new shapes. The problem was, most of them went nowhere. And the stakes couldn't be higher, because the wrong bet wouldn't just slow us down. It would set the entire semiconductor roadmap back by a decade. And eventually, the industry wasn't looking for a next upgrade, but for a reinvention. And if any place can pull off a miracle, it was IMEC. After years of failed ideas and dead ends, the answer turned out to be very simple. And it started with a rough sketch on a whiteboard. And they asked a deceptively simple question. If this tall structure becomes unstable, what if we just flipped it sideways? And just imagine this simple idea became the second biggest turning point in microchip history, the invention of gate all around transistor. Instead of one tall fin, engineers stacked thin sheets horizontally, supported from below, making them far more stable to build. And this trick solved the mechanical problems that were killing FinFET. Right now, these devices are making their way into your next GPUs and smartphones. This innovation definitely bought us time, and it will carry us for another 3 chip generations. But it wasn't the end game, because right now, even with this gate all around innovation, we're still running out of space on a chip. And IMEC had to go back to the drawing board again. When cities ran out of space, they didn't stop building. They built skyscrapers. IMEC asked a bold question. Why not to do the same with transistors? Well, if we cannot shrink in 2D anymore, there is only one way. Up. Stack one device on top of another vertically, and you immediately double the transistor density. And now I will walk you through step by step how this technology is being invented. Before anyone touches a wafer, they spend years simulating this device, tweaking geometry, materials, and then try every variation, kill the weak ones until the numbers finally say this might actually work. And that's because every idea that here will save you years of effort and expenses in the fab. For CFAT, IMEC explored multiple ways to stack transistors. Most of them failed, but one had the pulse, and that became the path forward. And when it finally worked, it changed everything. For the first time in history, we began building chips in 3D, and soon you're gonna see it with your own eyes. I could not be more excited because right now I'm taking you inside the fab to see something almost no human eyes have ever seen. One of the greatest inventions in human history. First, I suit up in a clean room bunny suit. And of course, mine is like two
Eso se
sizes
gasta
too
en
big.
el puto
So I'm actually
vado,
looking like a
güey.
walking bed sheet with a
Por eso
bench.
está muriendo
They blast
tanta
me with
gente, nada
air
más por lo
just
que
to make
estamos a
sure I
punto de ver.
don't contaminate anything inside.
El objeto más
This place
sangriento
is
en la historia de la
insanely
humanidad, ¿no?
delicate. Clean rooms must be cleaner than clean. Inside, they're building technologies so tiny that one single hair, one speck of dust, and $1 million experiment is gone. Once we're in, we are heading straight to one of the coolest
Cabrón,
machines,
güey.
scanning electron microscope. This is the only way to actually see something that small. Because a modern transistor is about 100 times smaller than a virus. But here is a catch. The moment you look at it, you destroy it. You cannot actually see a 2 nanometer structure or even a 10 nanometer structure because our eyes simply aren't built for that. Our eyes only work when light bounces off the objects. But to bounce from something that small, light is simply too big. Its wavelength is hundreds of nanometers wide. It's like a giant wave trying to hit something smaller than a virus. That's why to see transistors, light, and typical microscopes are practically useless. We need something far more powerful than that. We need electrons. That's why we're gonna use this scanning electron microscope to see the unseen. First, we place the wafer inside the chamber. Inside, a thin beam of electrons scans across the surface of the chip. And this lets us zoom in hundreds of thousands of times. At first, what you see looks like simple lines. But as we increase magnification 20,000 times, 50,000 times, 150,000 times, patterns begin to appear. What we see right now are metal contacts that lead to the device. They are like tiny highways carrying electric